All right, now we're going to look at the focus and directrix of a parabola. First off, these parabola formulas you may not have seen before, because these specifically help you find the focus and directrix. But essentially, this is some form, right? You have x squared to some y, right? And then you have y squared to some x. So if you think of the basic like x squared equals y, that's probably a type that you're very familiar with, right? Something like that. So that's what this first type is, right? The arrows kind of are vertical, and meaning, right, they could go down like this, but regardless, they're vertical. Now the y squared equals x case is horizontal, meaning like this, or perhaps going the other way, could be shifted, stretched, whatever. But those are the two basic forms, right? Okay, so now what are the focus and directrix? So, best to see with the picture. So I'm going to go ahead and just draw a parabola. We'll keep it easy, something that we can understand very easily, right? So there's basically, the idea is there's some point in the center called the focus, and then there's some line underneath called the directrix. And the idea is that if we grab any point on the parabola, let's see if I did it right, the distance from the directrix and the distance to the focus are the same. Call it some d. Okay? So, again, d and d. Right, so even if we grab all the way over here, again, if I drew it right, the distance from there and the distance there is the exact same. And so then right, that's what the focus and directrix are. So now the question is, how do we get them? And it's actually not too bad. So let's go ahead. So first off, you need it in this form, but then once it's in this form, you just take a and you just divide it by 4. And that's how you can get both, right? So hang on now. What does that represent? So in our picture, actually, that p-value on there that you just saw, that represents this distance, which also, think about it, right? Think about this point here. In order for this to be the same distance from the vertex and the directrix, then this distance has to be the same as this distance. So p actually also represents the distance to the directrix. So if you take your vertex, right, and you take the value so in this case, right, if you take the y value and you add p, you would get up to the focus. If you subtract p, you would get to the directrix. Remember, this would be a point, and this one is a line. So it should probably be y is equal to, let's call it y1 minus p. My notation's a little bad, but I think you get the point. Something I do want to call attention to real quick before I move on is, hypothetically, what if we had something like this, right? And so, we'd still have this focus in this directrix, and you would solve for your vertex, right? And then you would solve for your p-value. But notice now that p is getting added to the x, is getting added to the x and not the y, right? So this would be, and then also notice that the directrix is now an x equals line rather than a y equals line, right? The other cases, right, hypothetically, if we went downward, right, rather than adding to get to the focus, you would subtract p to get to the focus, and then you would add to get to the directrix. So you do just have to be careful with your directions. So it's important to mess around with this and kind of figure out what the direction is. All right. And that's focus and directrix. Mess with it a little bit. Try plugging these forms into a calculator with different values and see how these different formulas look. But that is pretty much it.